Right, so now this one's going to be a harder example, converting to vertex form when you got a leading coefficient that's not 1. And so in this case, it's -2. So the first step is you got to factor out this out of these two terms. So y equals -2, and I'm going to factor that out because I wanted this to be 1. So it'd be x squared plus 2x. Okay. Then you're going to take b, which is 2 now, divide it by 2 and square it. 2 divided by 2 is 1. 1 squared is 1. Okay. I'm going to add 1 into this expression here. Now, I can't just add 1 without offsetting it. Now, but I'm not just adding 1. I'm adding 1 times -2. So I'm really adding -2. How do I offset adding -2? I add +2. Okay. So that's a little trick there. And then I can factor this. What multiplies to 1 adds to 2, 1 and 1, and plus 2. So there's your, now I should put y equals here. I apologize. I ran out of room. Y equals -2. Okay, so there's your vertex form. Let's find the vertex first. The vertex is just going to be the opposite of that for the x, and then that's the y. So it'd be -1, 2. Might plot that. Let's go ahead and plot that. -1, 2. Okay, there's my vertex. The axis of symmetry is x equals whatever x is in the vertex. So x equals -1. Now this one has a negative leading coefficient. So it's a negative leading coefficient. So this one's going to be going downward. So it's going to have a maximum. It's going to be concave down. These are hints that are going to help me graph this, okay? The y-intercept is the constant at the end of standard form. Well, there's no constant here. So the y-intercept is 0, 0. It's just 0. There's nothing out there. It's just plus 0. We're going to y-intercept at 0, 0. So now I'm going to go ahead and graph this. This will be the top point. Going to be going down here and going to be going down here. Now, whoops, I went a little too wide there. Notice that it's negative going down, but 2 means it's going to be narrower, twice as narrower. So this should be twice as narrower than normal. Okay, we're going to kind of talk about that here in a moment. Okay, so domain, how far left does it go? It goes forever to the left, so -infinity. Oh, I forgot about zeros. How far right does it go? Infinity. By the way, how many times will this touch the x-axis? Twice, so this will have 2 zeros. Okay. We don't know. Well, we know one of them 0, 0. Not for sure on the other one, like just by looking at the graph there. The range, how far down does it go? -infinity. How far up does it go? It goes up to 2. Okay. Now let's talk about the transformations from the parent function y equals x squared. So this time we've got actually 4 moves. We got 4 moves here. Okay. So first off, it shifts left 1, up 2. Now, this negative, or this, let's talk about the negative, I guess. Negative means it has a vertical flip. So if a negative to the whole thing means a vertical flip because of the negative. And then we also have the 2. And the 2, since it's bigger than 1, that'd be a stretch. And a vertical stretch of factor 2. Okay, compressions between 0 and 1, stretch, factor 2 stretch makes it narrower. So those are your transformations from the original.